Welcome. Docker. Deploying your first Docker container. What is Docker? Docker describes themselves as an open platform for developers and system admins to build, ship, and run distributed applications. We'll start the scenario. Step 1. Running a container. The first task is to identify the name of the Docker image. Using the search command, Jen has identified that the Redis Docker image is called Redis and wants to run latest release because Redis is a database. Jen wants to run it as background. By default, Docker will run command in the foreground. To run the background, the option D needs to be specified. Just try. Continue. Step 2. Finding running containers. The launch container is running in the background. The docker ps command listed as running contains the email used to start the container and uptime. Continue. Step 3. Accessing Redis. After reading the documentation, they discovered that ports are bound when containers are started using -p or spot container port option. Jane also discovers that it's useful to define a name when starting the container. This means she doesn't have to use bash pipping or keep looking up the name when trying to access the logs. Jane finds the best way to solve her problem of running Redis in the background with the name of Redis hotspot on port 6379 using the following command. Yes, just continue. Step 4. Accessing Redis. The problem with running processes on a fixed port is that you can only run one instance. Jane would prefer to run multiple Redis instances and configure the application depending on which port it is running on. After experimenting, Jane discovers that just using the option -p6379 enable her to expose Redis but on a randomly available port. She decided to test her theory using following command. While this works, she now doesn't know which port has been assigned. Thankfully, this is discovered via following command. Yes. Jane also finds that listing the container displays the port mapping information. Continue. Step 5. Persisting data. Using the Docker Hub documentation for Redis, investigated that the official Redis image stores logs and data into a data directory. Any data which needs to be saved on the Docker host and not inside container should be stored in /opt/docker/data/redis. The complete command to solve the task is yes. Let's see what happened. Yes. Just continue. Step 6. Running a container in the foreground. The command docker run ubuntu ps launch an ubuntu container executes the command ps to view all the processes running in a container. Using docker run it ubuntu bash allows Jane to get access to a bash shell inside the container. Let's see the summary. Yes, completed the scenario. Thank you. Deploy static HTML website as container. In this scenario, you will learn how to create a Docker image for running a static HTML website using NGINX. The scenario will explain how to build a Docker image running nginx with your HTML site. The aim to help you understand how to create and run Docker images created by yourself. We'll start scenario. Step 1. Create Docker file. Create your Docker file for building your image by copying the content below into the editor. Right? Just continue. Step 2. Build Docker image. Build our static HTML image using the build command below. Just click on. You can view a list of all images on the host using Docker image. Continue. Step 3. Run. Launch our newly built image providing the friendly name and tag as its web server. Bind port 80 to our host using the -p parameter. Just use this command. Once started, you will be able to access the result of port 80 via curl docker. To render the request in the browser, use following link. Just click on it. Hello world. You can see hello world. Now we will see the summary. Thank you. Building container image. This scenario explains how to build an image based on your requirement. Start scenario. Step 1. Base images. Creating a doc file. The first line of the doc file should be from nginx 1.11 alpha. Make the changes in the Docker file editor. Within the environment, a new Docker file will be created within the content of the editor. To complete this step, you need to execute following code. Step 2. Running commands. To complete this step, you need to execute the following code. Step 3. Exposing ports. We want our web server to be accessible via port 80 at the relevant expose line to the Docker file. To complete this step, you need to execute the following code. Continue. Step 4. Default commands. The commands to run nginx is nginx-g daemon of semicolon. Set this as the default command in the Docker file. Okay, just continue. Step 5. Building containers. Using the docker build command to build the image, you can give the image a friendly name by using the -t. You can use docker image to see a list of the images on your local machine. You can see the result. To complete this step, you need to execute the following code. Okay, you can see the process. Yes, it's running, still running. Yes, just continue. Step 6. Launching new image. Launch an instance of your newly built image using either id result from the build command or the friendly name you assign it. You can access the launched web server via the hostname docker. After launching the container, the command, you can use this command, will return our index file via nginx and the image we built. You can check the container is running using Docker PS. Great. To complete this step, you need to execute the following code. Okay, just summarize the scenario. Thank you. Dockerizing Node.js applications. This scenario continues to explore how to build and deploy your application as Docker container. This scenario explores how to deploy a Node.js application within a container. Start scenario. Step 1. Base image. As we described in the previous scenario, all images started with a base image, ideally as close to your desired configuration as possible. Node.js has pre-built images available with tags for each release version. To complete this step, you need to execute the following code. Okay, just continue. Step 2. npm install. In this previous set, we configured the foundation of our configuration and how we want the application to be deployed. The next stage is to install the dependencies required to run the application for Node.js. This means running npm install. Add Docker file lines. The following two lines are required to order Dockerfile to run npm install. Just click on this. Yes. Copy the lines to the Dockerfile now so they can be used in the build later. Just see solution. Yes, same. Just continue. Step 3. Configuring application. Deploy application. Create the desired steps in the Dockerfile to finish the deployment of the application. To complete this step, you need to execute the following code. Okay, just continue. Step 4. Building and launching container. To launch your application inside the container, you first need to build an image. The command to build the image is, click on this command. Yes, yes, still it's running. Yes, still running. Yes, still running. Still running. Yes, the command to launch the build image is run this command. Okay, testing container. You can test the container is accessible using curl. If the application responds, then you know that everything has correctly started. Run this command. Continue. Step 5. Environment variables. Docker images should be designed that they can be transferred from one environment to the other without making any changes or requiring to be rebuilt. By following this pattern, you can be confident that if it works in one environment, such as staging, then it will work in another, such as product. With Docker, environment variables can be defined when you launch a container. Example, run this command. Yes, just we'll see the summary. Thank you. Optimizing Docker file with on-build. In this scenario, we will look at how you can optimize Docker file using the on-build instruction. Let's start scenario. Step 1. On-build. While Docker are executed in order from top to bottom, you can trigger and instructs to be executed at a later time when the image is used as the base for another image. Just continue. Step 2. Application Docker file. With all of the logic to copy the code, install our dependencies and launch our application. The only aspect which needs to be defined on the application level is which ports to expose. This will be created in the environment for you. The steps to build and launch Docker file in covered in the next step. Continue. Step 3. Building and launching container. The Docker file from the previous step has been created for you. Building the images based on the on-build Docker file is the same as before. The on-build commands will be executed as if they were in the base Docker file. Build and launch. The command to build the image is, please run this command. Still running. Still running. Still running. Wait and watch. Still running. Still running. After finishing, the command to launch the build image is, please run this command. Test container. You can test the container is accessible using curl. If the application responds when you know that everything has correctly started, just run this command. Yes, you can see the result. Yes, now we can see the summary. Thank you. Ignoring files. In this scenario, we'll explore how you can ignore certain files from ending up inside a Docker image that can introduce security risks. This scenario also investigates how you can reduce the build time by ignoring which file are sent to the Docker build context. Start scenario. Step 1. Docker ignore. The prevent sensitive files or directories from being included by mistake in image. You can add the name a file called .docker ignore. Example, a Docker file copied the working directory into the Docker image. As a result, this would include potentially sensitive information such as a password file, which we want to manage outside the image. View the Docker with following command. Yes. So, okay. Build the image with following command. Look at the output using following command. This will include the password file. Ignore files. The following command would include passwords .text in our .ignore file and ensure that it didn't accidentally end up in the container. The Docker ignore file would be stored in source control and share with the team to ensure that everyone is consistent. Run following command. Run following command. To look at the output, use following command. Yes. Just continue. Step 2. Docker build context. You can see the 100-meter impact by executing following this command. Okay. Still running. Yes, just continue. Step 3. Optimize build. In the same way we use the Docker ignore file to exclude sensitive files, we can use it to exclude files which we don't want to be sent to the Docker build context during the build. To speed up our build, simply include the file name of the large file in the ignore file. Just run this command. When we rebuild the image, it will be much faster as it doesn't have to copy the 100M file. Just run following command. This optimization has a greater impact when ignoring large directories such as .git. We will see the summary. Thank you. Data containers. This scenario will introduce the advantages of using data containers. Start scenario. Step 1. Create container. Data containers are containers which sole responsibility to be a place to store or manage data. Create a data container for storing configuration file using following command. Continue. Step 2. Copy file. With the container in place, we can now copy file from our local client directory into the container. To copy file into a container, you use the command docker cp. The following command will copy the config.conf file into our data container and the directory config. Okay, just continue. Step 3, mount volumes from. Now our data container has our config. We can reference to container when we launch dependent containers require the configurations file. When we list the conf directory, it will show the files from the attached container. Yes, click on the command. Okay, continue. Step 4, export or import containers. If we wanted to move the data container to another machine, then we can export it to a .tar file. Use this command. The command docker import data container.tar will import the data container back into Docker. Now you can see the summary. Thank you. Communicating between containers. This scenario explores how to allow multiple containers to communicate with each other. The steps will explain how to connect a data store, in this case, Redis, to an application running in a separate container. Just start the scenario. Step 1. Start Redis. Run a Redis server with the friendly name of Redis-server, which will connect to the next step. This will be our source container. Just run following command. Okay, continue. Step 2. Create link. In this example, we bring up Alpine container which is linked to our Redis server. We will define the alias as Redis. When a link is created, Docker will do two things. First, Docker will set some environment variables based on the link to the container. This environment variable give you a way to reference information such as ports and IP address via known names. You can output all the environment variable with the env command. Okay. Secondly, Docker will update the host file of the container with an entry for our source container with three names: the original, the alias, and the #ID. With a link created, you can ping the source container in the same way as if it were a server running in your network. Just run following command. Okay, continue. Step 3. Connect to app. With the link created, applications can connect and communication with the source container in the usual way, independent of the fact both services are running in containers. Just run the command. Okay. Sending an HTTP request to the application will store the request in Redis and return a count. If you issue multiple requests, you will see the counter increment as item R persist. Just run the command. Continue. Step 4. Connect to Redis CLI. In the same way you can connect source containers to application, you can also connect them to their own CLI tools. Please run the following command. Type quite to exit the CLI. Okay. Now we can see the summary. Thank you. Docker networks. This scenario explores how to create a Docker network allowing containers to communicate. We'll also explore the embedded DNS server added in Docker 1.10. Start the scenario. Step 1. Create network. The first step is to create a network using the CLI. This network will allow us to attach multiple containers which will be able to discover each other. To start with, create the network with our predefined name. Let's use this command. When we launch new containers, we can use the -net attribute to assign which network they should be connected to. Let's run the command. Continue. Step 2. Network communication. Unlike using links, Docker network behave like traditional networks where nodes can be attached or detached. The first thing you'll notice is that Docker no longer assigns environmental variable or updates the host file or containers. Explore using the following two commands and you'll notice it no longer mentions other containers. Okay, okay, okay. Run this command also. Just continue. Step 3. Connect two containers. The first task is to create a new network in the same way. Please run this command. When using the connect command, it is possible to attach existing containers to the network. Run this command. When we launch the web server, given it's attached to the same network, it will be able to communicate with our Redis instance. Run the command. Still running. Still running. Yes, now you can test it using curl docker 3000 command. Okay, you can see the result. Continue. Step 4. Create aliases. The following command will connect our Redis instance to the front-end network with the alias of DB. When containers attempts to access a service via the name DB, they will be given the IP address of our Redis container. Continue. Step 5. Disconnect containers. With our network creates, we can use the CLI to explore the details. The following command will list all the networks on our host. Yes, you can see the result. We can then explore the network to see which containers are attached and their IP addresses. Okay, you can see the result. The following command is connect the Redis container from the front-end network. Yes, run the command. Okay. Now we can see the summary. Thank you. Persisting data using volumes. In this scenario, you will learn how to use Docker volumes to persistent data within containers. Docker volumes allow directories to be shared between containers and container versions. We'll start scenario. Step 1. Data volumes. Docker volumes are created and assigned when containers are started. Data volumes allow you to map a host directory to a container for sharing data. This mapping by direction. It allows data stores on the host to be accessed from within the container. It also means data saved by the process inside the container is persisted on the host. This example will use Redis as a way to persist data. Just run the command. We can pipe data into a Redis instance using the following command. Redis will save this data to disk. On the host, we can investigate the map directory which should contain the Redis data file. Okay. This same directory can be mounted to a second container. One usage is to have a Docker container performing backup operations on your data. Just run command. Okay. Continue. Step 2. Shared volume. In this case, we are mapping our Redis containers volume to an Ubuntu containers. The \del directory only exists within our Redis container. However, because of volumes from our Ubuntu container can access the data. Run the command. Continue. Step 3. Read-only volumes. Mounting volumes gives the container full read and write access to the directory. You can specify read-only permissions on the directory by adding the permissions to the mount. If the container attempts to modify data within the directory, it will error. Please run the command. Now we see the summary. Thank you. Managing log files. This scenario will explore the different ways you can handle logging output from your application and services while running as containers. Step 1. Docker logs. When you start a container, Docker will track the standard out and standard error outputs from the process and make them available via the client. In the background, there is an instance of Redis running the name Redis server. Using the Docker client, we can access the standard out and standard error outputs using this command. Okay, great. Continue. Step 2. The command below will redirect the Redis logs to syslog. Continue. Step 3. Disable logging. The third option is to disable logging on the container. This is particularly useful for containers which are very verbose in their logging. When the container is launched, simply set the log driver to none. No output will be logged. The inspect command allows you to identify the logging configuration for a particular container. The command below will output the log config section for each of the containers. Step 1. Server created in step 2. Server created in this step. We will see the sum. Thank you. Ensuring uptime. In the previous scenario, we launched some containers, but like any process, containers can crash. This scenario will explore how you can keep containers live and automatically restart them if they crash unexpectedly. Step 1. Stop on fail. Docker considers any containers to exit with a non-zero exit code to have crashed. By default, a crash container will remain stopped. Example, we create a special container which output a message and then exists with code 1 to simulate crash. You can launch an instance using run this command. If you list all the containers including stop, you will see the container has crashed. While the logs will output our message, which in real life would hopefully indicate information to help us diagnose the issue. Continue. Step 2. Restart on fail. Depending on your scenario, restarting a failed process might correct the problem. Docker can automatically retry to launch Docker a specific number of times before it stops trying. As we can see from the logs, it was launched on 3 occasions. Continue. Step 3. Always restart. Finally, Docker can always restart a failed container. In this case, Docker will keep trying until the container it is explicitly told to stop. You can view the restart attempting via the log. Yes, you can see the result here. Now we will see the summary. Thank you. Docker metadata and labels. This scenario guides you though creating and querying the metadata for containers and images. Start scenario. Step 1. Docker containers. Labels can be attached to containers when they are launched via Docker run. A container can have multiple labels attached to them at any one time. Notice in this example, because we are using the labels are for use with the CLI and not an automated tool. We are not using the DNS notation format. Run the command. This line creates 2 labels in the file, one for the user and the second assign a role. The label file option will create label for each line in the file. Continue. Step 2. Docker images. Labeling images work in the same way as containers but are set in the Docker file when the image is built. When the container has launched, the labels of the image will be applied to the container instance. Just continue. Step 3. Inspect. Labels and metadata are only useful if you can view or query them later. The first approach to viewing all the labels for a particular container or image is by using Docker inspect. By providing the running container's friendly name or hash ID, you can query all of its metadata. Inspecting images work in the same way, however the JSON format is slightly different, naming it container config instead of config. Great. Just continue. The Docker ps command allows you to specify a filter based on the label name and value. For example, the query below will return all the containers which have a user label key with the value katakoda. The same filter approach can be applied to images based on the labels used when the image was built. Just continue. Step 5. Daemon labels. Labels are not only applied to images and containers but also the Docker daemon itself. When you launch an instance of the daemon, you can assign it labels to help identify how it should be used. For example, if it's a development or production server, or if it is more rooted to particular roles such as in database. Now we will see the summary. Thank you. Load balancing containers. In this session, we will explore how you can use the NGINX web server to load balance requests between two containers running on the host. Step 1. NGINX proxy. In this scenario, we want to have an NGINX service running which can dynamically discover and update its load balance configuration when new containers are loaded. Thankfully, this has already been created and is called NGINX proxy. Use the command below to launch NGINX proxy. Because we are using the default host, any request which come in will be directed to the container that has been assigned the host proxy. You can make requests to the web server using curl command. Okay, now continue. Step 2. Single host. In this scenario, we will set our host to match our default underscore host. So it will accept all requests. Sometimes it takes a few seconds for NGINX to reload, but if we execute a request to our proxy using curl, then the request will be handled by our container. Step 3. Cluster. Launch a second container using the same command as we did before. If we execute a request to our proxy using curl command, then the request will be handled by our first container. A second HTTP request will return a different machine name, meaning it was dealt with by our second container. Step 4. Generated NGINX configuration. While NGINX proxy automatically creates and configures NGINX for us, if you're interested in what the final configuration looks like, then you can output the complete config file with docker exec as shown below. Additional information about when it reloads configuration can be found in the logs using dockerlog MPIX. Just now see the summary. Thank you. Orchestration using Docker Compose. When working with multiple containers, it can be difficult to manage the starting along with the configuration of variables and links. To solve this problem, Docker has a tool called Docker Compose to manage the orchestration of launching of containers. Start scenario. Step 1. Defining first container. In this scenario, we have a Node.js application which requires connecting to Redis. To start, we need to define our docker compose.yml file to launch the Node.js JS application. Copy the following YML into the editor. This will define a container called web, which based on the build of the current directory. Continue. Step 2. Define settings. Docker Compose supports all of the properties which can be defined using Docker run. Copy editor. The same format is used for other properties such as ports. Copy it to editor. Just continue. Step 3. Defining second container. Define a second container with the name radius which uses the image's radius. Following the YML format, the container detail would be copy to editor. Just continue. Step 4. Docker up. With the created Docker Compose y.yml file is placed, you can launch all the applications with a single command of up. If you want to bring up a single container, then you can use up name. Launch your application using this command. Okay, continue. Step 5. Docker management. Not only can Docker Compose manage starting containers, but it also provides a way to manage all the containers using a single command. For example, to see the details of the launched containers, you can use Docker Compose vs. Yes, you can see the result. To access all the logs via a single stream, you use Docker Compose log. Yes, you see the result. Other commands follow the same pattern. Discover them by typing Docker Compose. Okay, now continue. Step 6. Docker scale. Scale the number of web containers you are running using the command docker compose scale web equal 3. Yes, you can scale it back down using this command. Yes, still running. Okay, continue. Step 7. Docker stop. As when we launch the application to stop a set of containers, you can use the command docker-compose space stop. Let's try. Still running it. Yes. To remove all the containers, use the command docker-compose space rm. The stars are you sure? Just type y and enter. Okay. Now you will see the summary. Thank you. Docker stats. In this scenario, we will explore the built-in metrics provided by Docker to give additional visibility to the running containers. In future, we will investigate more details about running Docker in production. Start the scenario. Step 1. Single container. The environment has a container running with the name nginx. You can find the stats for the container by using Docker stat nginx. Okay. Yeah, so you can see the result is still running, still running, still running, still running. This launches a terminal window which refreshes itself with live data from the container. To quit, use Ctrl+C to stop run in progress. Will I tried Ctrl+C. Okay, just continue. Step 2. Multiple containers. The built-in Docker allows you to provide multiple names, IDs, and display their stats within a single window. By combining the two, we can take the list of all our running containers provided by Docker PS and use them as the argument for Docker stats. This gives us an overview of the entire machine containers. Run this command. Yes, you can see the result. To quite use Ctrl C, stop run in progress. We will try Ctrl C. Yes, you can see it's quite. Now we see the summary. Thank you. Creating optimized Docker images using multi-stage builds. In this scenario, you will learn how to use the multiple stage build functionality to make smaller, more optimized images. Create Docker file. The multi-stage feature allows a single Docker file to contain multiple stages in order to produce the desired optimized Docker image. Start by developing sample Golang HTTP server. Just try it out. Yes, you can see the page. We will go back to the lesson. This currently using a two stages Docker build approach. This scenario will create a new Docker file that allows the image to be built using a single command. Oh, you can see the result. Multiple stage Docker file. Using the editor, create multi-stage Docker file. The first stage using the Golang SDK to build a binary. The second stage copies the resulting binary into a optimized Docker image. Copy to editor. Yes, go ahead. Just try that URL. What it would be. Still running. Ah, yes, it's blocked. Just continue. Step 2. Build multi-stage Docker image. With the new syntax for the Docker file in place, the build process is identical to previous. Create the desired Docker image using the build command below. The result will be two images, one untagged that was used for the first stage and the second smaller image, our target image. It's running. extracting and pull complete. Still running, still running, yes, still running. Still running. Yes, finish. Just type Docker image. Okay, you can see there is that. There is Ubuntu Alpine Golang. Continue. Test image. The image can be launched and deployed without any changes required. Just run this command. Yes, now try curl localhost. Wow. Now we can see the summary. Yes, thank you. Formatting PS output. In this scenario, we will learn how to use the format parameters to pretty print output from Docker, PS and Docker inspect. Example 1. Name and images as table. The format of Docker PS can be formatted to only display the information relevant to you. Start by launching an example container. Okay. The standard format ps command outputs the name, image, use command, uptime and port information. To limit which columns are displayed, use the format parameter. The parameter allows pretty printing containers using a Go template syntax. See, as it is using Go templates, it includes helper functions such as table. Yes. Let's continue. Example 2. List IP address. However, the format parameter allows supports displaying data that is already exposed via the Docker PS command. If you wanted to include additional information such as the IP address of the container, then the data needs to come via Docker inspect. The format parameter can then access all of the container information. Below is an example of listing all the IP addresses for the running containers. Yes, you see the summary. Thank you. Docker orchestration. Getting started with Swarm mod. In the scenario, you will learn how to initialize a Docker Swarm mod cluster and deploy networked containers using the built-in Docker orchestration. The environment has been configured with 2 Docker hosts. Step 1. Initialize Swarm mod. Swarm mod is built into the Docker CLI. You can find an overview the possibility commands via Docker Swarm --help. The most important one is how to initialize swarm mode. Initialization is mode via init. Just survive Docker Swarm init. After running the command, the Docker engine knows how to work with the cluster and becomes the manager. The results of the initialization is a token used to add additional nodes in a secure fashion. Keep this token safe and secure for future use when scaling your cluster. You know, step 2, join cluster. The first task is to obtain the token required to add the worker to the cluster. For the demonstration purpose, we will ask the manager what the token is via Swarm join token. It products. This token should be stored securely and only accessible by trusted individuals. Run this command. Okay. On the second host, join the cluster by requesting access via the manager. The token is provided as an additional parameter. Okay. By default, the manager will automatically accept new nodes being added to the cluster. You can view all nodes in the cluster using Docker node ls. Yes, you can see the result. Continue. Step 3. Create overlay network. The following command will create new overlay network called Skynet. All containers registered to this network can communicate with each other, regardless of which node they are deployed onto. Okay, continue. Deploy service. In this case, we are deploying the Docker image katakoda /docker python http server. We are defined a friendly name of a service called http and that it should be attached to the newly created Skynet network. Just try this command. Yes, you can view the services running on the cluster using the CLI command. Yes, you can see the result. As containers are started, you will see them using the ps command. You should see one instance of the container on each host. This containers on the first host, type docker ps. This containers on the second host, docker ps. If we issue an HTTP request to the public pod, it will be processed by the two containers, curl docker. Okay, just continue. Step 5. Inspect state. The service concept allows you to inspect the health and state of your cluster and the running application. You can view the list of all the tasks associated with a service across the cluster. In this case, each task is a container. Type docker service ps http. You can view the details and configuration of a service via docker service inspect. Type -petty http. On each node, you can ask what task it is currently running. Self refers to the manager node leader, Docker node ps self. Yes. Using the ID of a node, you can query individual hosts. Docker node ps toler, which is brackets docker node ls -q -n1. Yes. Continue. Step 6. Scale service. At present, we have two load balanced containers running, which are processing our request. Start curl docker. The command below will scale our HTTP service to be running across 5 containers. Yes. On each host, you will see additional nodes being started. Okay, the load balancer will automatically be updated. Request will now be processed across the new containers. Try issuing more commands via curl docker. Try scaling the service down to see the result. See the summary. Thank you. Docker Swarm Mode Playground. Docker is an open source project that automates the deployment of applications using containers, providing an additional layer of abstraction and automation on top of Linux. This playground provides a personalized sandbox environment for you to learn and explore Docker. What are playgrounds? Playgrounds give you a configured environment to start playing and exploring using an unstructured learning approach. Playgrounds are great for experimenting and trying samples. To learn more about the technology, then start with one of our lab. Start scenario. Create swarm cluster. Initialize. Just type Docker Swarm init. Yes, type this. Run this command. Run this command. Just see the summary. Okay. Docker frustration. Getting started with Swarm mode. In this scenario, you will learn how to initialize a Docker Swarm mode cluster and deploy network containers using the built-in Docker orchestration. The environment has been configured with two Docker hosts. Step 1. Initialize Swarm. Swarm mode is built into the Docker CLI. You can find an overview the possibility command via Docker Swarm help. The most important one is how to initialize Swarm mode. Initialize is done via init. Docker Swarm init. Continue. Join cluster. The first task is to obtain the token required to add a worker to the cluster. For demonstration purposes, we'll ask the manager what the token is via Swarm join token in production. In production, this token should be stored securely and only accessible by trusted individuals. On the second host, join the cluster by requesting access via the manager. The token is provided as an additional parameter. By default, the manager will automatically accept new nodes being added to the cluster. You can view all nodes in the cluster using this. Continue. Step 3. Create overlay network. The following command will create a new overlay network called Skynet. All containers registered to this network can communicate with each other regardless of which node they are deployed onto. Deploy service. Just run this command. You can view the services running on the cluster using CLI command. Okay. As containers are started, you will see them using the ps command. You should see one instance of the container on each host. List container on the first host. List containers on the second host. If we issue an HTTP request to the public port, it will be processed by the two containers. Curl Docker. Continue. Step 5. Inspect state. State. The service concepts allow you to inspect the health and state of your trust and the running application. You can view the list of all the tasks associated with a service across the cluster. In this case, each task is a container. You can view the details and configuration of a service via this command. On each node, you can ask what task it is currently running. Self refers to the manager node leader. Using the ID of a node, you can query individual hosts. Continue. Step 6. Scale service. At present, we have two load balanced containers running, which are processing our requests. Just type curl docker. The command below will scale our HTTP service to be running across 5 containers. On each host, you will see additional nodes being started. The load balancer will automatically be updated. Request will now be processed across the new container. Try issuing more commands via curl docker. Now see the summary. Thank you. Docker orchestration. Create overlay network. In this scenario, you will learn how to use overlay network as part of Swarm mode. Overlay networks allow containers to communicate as if they are on the same host, and the covers they use VXLAN features of the Linux kernel. Step 1. Initialize Swarm mode. By default, Docker works as an isolated single node. All containers are only deployed onto the engine. Swarm mode turns it into a multi-host clusters aware engine. To use the secret functionality, Docker has to be in Swarm mode. This is enabled via Docker Swarm init. Execute the command below on the second host to add it as a worker to the cluster. Let's continue. Step 2. To create the overlay network, use the CLI and define the driver. Networks can only be created via a Swarm manager node. The network name would be app1 network. All the networks can be viewed using Docker Network ls. It expected for the network not to appear on the worked nodes. The managers node handles network creation and services being deployed. Use Docker Network ls. Yes. Just continue. Deploy backend. The following will deploy a Redis service using the network. The name of the service will be Redis that can be used for discover via DNS. Continue. Step 4. Deploy frontend. Create the new service with the command below. With two nodes deployed, each container will be deployed onto different hosts. Docker ps. They'll use the overlay network and DNS Discover to communicate. Sending HTTP request will persist the IP of the client in Redis curl Docker. As the service has been configured and deployed using Swarm mode, it will take advantage of the load balancing discussing in our scenario. Just click on it. Okay. Summary.